Hey guys, this is Akansha and welcome to Tech Master Ernie. In our previous session, I have covered the Flick's first law under diffusion topic. So do watch Advanced Electronics playlist for the better clarity of the subject. In our today's session, we will going to understand the Flick's second law. In Flick's first law, we have seen that the diffusion flux J is directly proportional to the D, which is diffusion constant, or concentration gradient. Here D is proportional to temperature, so our flux is proportional to temperature, anti-proportional to the distance and proportional to the difference of the concentration. And our concentration will always go from higher concentration to lower concentration. So that is why here is a negative sign. So now we haven't considered the time consideration in the Flick's first law. So we will consider time in the second Flick's law. So this is the extension of Flick's first law. Here the flux is a function of both space as well as time. So Flick's second law relate the change of the concentration with respect to change in time as well as the space. So it states that the derivative of the flux with respect to space is equals to minus of derivative of the concentration with respect to time. So this is what is called Flick's second law. In this, you can also understand it by our continuity equation. Del dot J is equals to minus rho dV by dt. This is the same phenomena here, that the derivative in the space is equals to concentration derivative at the time. So this is our Flick's second law. In this way, our diffusion flux is also proportional to the temperature and time as well as temperature, time as well as concentration. So now our J, now let us understand here the derivation, the final statement here. We know in our first Flick's law, J is equals to minus d dn upon dx. This is our first law. And our second law states this. So if I will differentiate my first equation with respect to x, then it will be rho j upon rho x is equals to minus d, and it will derivate. So dou square n upon dou x square. Now I can use dj upon dx is equals to minus dn upon dt here. So I will use this here and I will equate it, and now I will get this second order differential equation. So by this second order differential equation, if I will calculate the value of n, or I will try to calculate the function of n, it will be dependent upon the space as well as time. So now we can conclude that the concentration is function of space as well as time. So here n is a concentration, d is diffusion, x is space and t is time. So in the whole process we can say that the concentration is proportional to temperature and also proportional to time and anti-proportional to distance. So if I will increase the distance, my concentration will decrease. If I will increase the temperature, my concentration will increase. And if I increase the time, my concentration will also increase. So this is the whole picture of the concentration. So in the next video, we will going to understand two different methods of diffusion. So that's it for the day. Thank you so much.